Earth is the third planet from the Sun and the only astronomical object known to harbor life. This is enabled by Earth being a water world, the only one in the solar system sustaining liquid surface water. Almost all of Earth's water is contained in its global ocean, covering 70.8% of Earth's surface. The remaining 29.2% of Earth's surface is land, most of which is located in the form of continental land masses within one hemisphere, Earth's land hemisphere. Most of Earth's land is somewhat humid and covered by vegetation, while large sheets of ice at Earth's polar deserts retain more water than Earth's groundwater, lakes, rivers, and atmospheric water combined. Earth's land is part of Earth's crust, consisting of several slowly moving tectonic plates, which interact to produce mountain ranges, volcanoes, and earthquakes. Earth has a liquid outer core that generates a magnetosphere capable of deflecting most of the destructive solar winds and cosmic radiation. Earth has a dynamic atmosphere, which sustains Earth's surface conditions and protects it from most meteoroids and UV light at entry. It has a composition of primarily nitrogen and oxygen. Water vapor is widely present in the atmosphere, forming clouds that cover most of the planet. The water vapor acts as a greenhouse gas and, together with other greenhouse gases in the atmosphere, particularly carbon dioxide, CO2, creates the conditions for both liquid surface water and water vapor to persist via the capturing of energy from the sun's light. This process maintains the current average surface temperature of 14.76 degrees Celsius, at which water is liquid under atmospheric pressure. Differences in the amount of captured energy between geographic regions, as with the equatorial region receiving more sunlight than the polar regions, drive atmospheric and ocean currents, producing a global climate system with different climate regions, and a range of weather phenomena such as precipitation, allowing components such as nitrogen to cycle. Earth is rounded into an ellipsoid with a circumference of about 40,000 kilometers. It is the densest planet in the solar system. Of the four rocky planets, it is the largest and most massive. Earth is about 8 light-minutes away from the Sun and orbits it, taking a year, about 365.25 days, to complete one revolution. Earth rotates around its own axis in slightly less than a day, in about 23 hours and 56 minutes. Earth's axis of rotation is tilted with respect to the perpendicular to its orbital plane around the Sun, producing seasons. Earth is orbited by one permanent natural satellite, the Moon, which orbits Earth at 384,400 kilometers, 1.28 light seconds, and is roughly a quarter as wide as Earth. Through tidal locking, the Moon always faces Earth with the same side, which causes tides, stabilizes Earth's axis, and gradually slows its rotation. Earth, like most other bodies in the solar system, formed 4.5 billion years ago from gas in the early solar system. During the first billion years of Earth's history, the ocean formed and then life developed within it. Life spread globally and has been altering Earth's atmosphere and surface, leading to the Great Oxidation Event 2 billion years ago. Humans emerged 300,000 years ago in Africa and have spread across every continent on Earth with the exception of Antarctica. Humans depend on Earth's biosphere and natural resources for their survival, but have increasingly impacted the planet's environment. Humanity's current impact on Earth's climate and biosphere is unsustainable, threatening the livelihood of humans and many other forms of life, and causing widespread extinctions. Earth has a rounded shape, through hydrostatic equilibrium, with an average diameter of 12,742 kilometers, 7,918 miles, making it the fifth largest planetary-sized and largest terrestrial object of the solar system. Due to Earth's rotation, it has the shape of an ellipsoid, bulging at its equator. Its diameter is 43 kilometers, 27 miles, longer there than at its poles. Earth's shape furthermore has local topographic variations. Though the largest local variations, like the Mariana Trench, 10,925 meters or 35,843 feet below local sea level, only shortens Earth's average radius by 0.17%, and Mount Everest, 8,848 meters or 29,029 feet above local sea level, lengthens it by only 0.14%. Since Earth's surface is farthest out from Earth's center of mass at its equatorial bulge, the summit of the volcano Chimborazo in Ecuador, 6,384.4 kilometers or 3,967.1 miles, is its farthest point out. Parallel to the rigid land topography, the ocean exhibits a more dynamic topography. To measure the local variation of Earth's topography, geodesy employs an idealized Earth producing a shape called a geoid. Such a geoid shape is gained if the ocean is idealized, covering Earth completely and without any perturbations such as tides and winds. The result is a smooth but gravitational irregular geoid surface, providing a mean sea level, MSL, as a reference level for topographic measurements. Earth's surface is the boundary between the atmosphere and the solid Earth and oceans. Defined in this way, Earth's shape is an idealized spheroid, a squashed sphere, with a surface area of about 510 million square kilometers, 197 million square miles. Earth can be divided into two hemispheres, by latitude into the polar northern and southern hemispheres, or by longitude into the continental eastern and western hemispheres. Most of Earth's surface is ocean water, 70.8% or 361 million square kilometers, 139 million square miles. This vast pool of salty water is often called the world ocean, and makes Earth with its dynamic hydrosphere a water world or ocean world. Indeed, in Earth's early history the ocean may have covered Earth completely. The world ocean is commonly divided into the Pacific Ocean, Atlantic Ocean, Indian Ocean, Antarctic or Southern Ocean, and Arctic Ocean, from largest to smallest. The ocean fills the oceanic basins, and the ocean floor comprises abyssal plains, continental shelves, seamounts, submarine volcanoes, oceanic trenches, submarine canyons, oceanic plateaus, and a globe-spanning mid-ocean ridge system. At Earth's polar regions, the ocean surface is covered by seasonally variable amounts of sea ice that often connects with polar land, permafrost, and ice sheets, forming polar ice caps. Earth's land covers 29.2%, or 149 million square kilometers, 58 million square miles of Earth's surface. The land surface includes many islands around the globe, but most of the land surface is taken by the four continental land masses, which are, in descending order, Africa, Eurasia, America, landmass, Antarctica, and Australia, landmass. These land masses are further broken down and grouped into the continents. The terrain of the land surface varies greatly and consists of mountains, deserts, plains, plateaus, and other landforms. The elevation of the land surface varies from a low point of 418 m, 1,371 foot, at the Dead Sea, to a maximum altitude of 8,848 meters, 29,029 feet at the top of Mount Everest. The mean height of land above sea level is about 797 meters, 2,615 feet. Land can be covered by surface water, snow, ice, artificial structures, or vegetation. Most of Earth's land hosts vegetation, but ice sheets, 10%, not including the equally large land under permafrost, or cold as well as hot deserts, 33%, occupy also considerable amounts of it. The pedosphere is the outermost layer of Earth's land surface and is composed of soil and subject to soil formation processes. Soil is crucial for land to be arable. Earth's total arable land is 10.7% of the land surface, with 1.3% being permanent cropland. Earth has an estimated 16.7 million square kilometers, 6.4 million square miles of cropland and 33.5 million square kilometers, 12.9 million square miles of pasture land. The land surface and the ocean floor form the top of Earth's crust, which together with parts of the upper mantle form Earth's lithosphere. Earth's crust may be divided into oceanic and continental crust. Beneath the ocean floor sediments, the oceanic crust is predominantly basaltic, while the continental crust may include lower density materials such as granite, sediments, and metamorphic rocks. Nearly 75% of the continental surfaces are covered by sedimentary rocks, although they form about 5% of the mass of the crust. Earth's surface topography comprises both the topography of the ocean surface, and the shape of Earth's land surface. The submarine terrain of the ocean floor has an average bathymetric depth of 4 kilometers, and is as varied as the terrain above sea level. Earth's surface is continually being shaped by internal plate tectonic processes including earthquakes and volcanism, by weathering and erosion driven by ice, water, wind, and temperature, and by biological processes including the growth and decomposition of biomass into soil. Earth's mechanically rigid outer layer of Earth's crust and upper mantle, the lithosphere, is divided into tectonic plates. These plates are rigid segments that move relative to each other at one of three boundaries types. At convergent boundaries, two plates come together; at divergent boundaries, two plates are pulled apart; and at transform boundaries, two plates slide past one another laterally. Along these plate boundaries, earthquakes, volcanic activity, mountain building, and oceanic trench formation can occur. The tectonic plates ride on top of the asthenosphere, the solid but less viscous part of the upper mantle that can flow and move along with the plates. As the tectonic plates migrate, oceanic crust is subducted under the leading edges of the plates at convergent boundaries. At the same time, the upwelling of mantle material at divergent boundaries creates mid-ocean ridges. The combination of these processes recycles the oceanic crust back into the mantle. Due to this recycling, most of the ocean floor is less than 100 ma old. The oldest oceanic crust is located in the western Pacific and is estimated to be 200 ma old. By comparison, the oldest dated continental crust is 4030 ma, although zircons have been found preserved as clasts within Eoarchean sedimentary rocks that give ages up to 4400 ma, indicating that at least some continental crust existed at that time. The seven major plates are the Pacific, North American, Eurasian, African, Antarctic, Indo-Australian, and South American. Other notable plates include the Arabian Plate, the Caribbean Plate, the Nazca Plate off the west coast of South America, and the Scotia Plate in the southern Atlantic Ocean. The Australian Plate fused with the Indian Plate between 50 and 55 ma. The fastest moving plates are the oceanic plates, with the Cocos Plate advancing at a rate of 75 mm/a, 3.0 in/year, and the Pacific Plate moving 52 to 69 mm/a, 2.0 to 2.7 in/year. At the other extreme, the slowest moving plate is the South American Plate, progressing at a typical rate of 10.6 mm/a, 0.42 in/year. Earth's mass is approximately 5.97 times 1024 kg, 5,970 yg. It is composed mostly of iron, 32.1% by mass, oxygen, 30.1%, silicon, 15.1%, magnesium, 13.9%, sulfur, 2.9%, nickel, 1.8%, calcium, 1.5%, and aluminum, 1.4%, with the remaining 1.2% consisting of trace amounts of other elements. Due to gravitational separation, the core is primarily composed of the denser elements: iron, 88.8%, with smaller amounts of nickel, 5.8%, sulfur, 4.5%, and less than 1% trace elements. The most common rock constituents of the crust are oxides. Over 99% of the crust is composed of various oxides of 11 elements, principally oxides containing silicon, the silicate minerals, aluminum, iron, calcium, magnesium, potassium, or sodium. The gravity of Earth is the acceleration that is imparted to objects due to the distribution of mass within Earth. Near Earth's surface, gravitational acceleration is approximately 9.8 meters per square second, 32 feet/s2. Local differences in topography, geology, and deeper tectonic structure cause local and broad regional differences in Earth's gravitational field, known as gravity anomalies. The main part of Earth's magnetic field is generated in the core, the site of a dynamo process that converts the kinetic energy of thermally and compositionally driven convection into electrical and magnetic field energy. The field extends outwards from the core, through the mantle, and up to Earth's surface, where it is, approximately, a dipole. The poles of the dipole are located close to Earth's geographic poles. Earth's rotation period relative to the Sun, its mean solar day, is 86,400 seconds of mean solar time, 86,400.0025 SI seconds. Because Earth's solar day is now slightly longer than it was during the 19th century due to tidal deceleration, each day varies between 0 and 2 milliseconds longer than the mean solar day. Earth's rotation period relative to the fixed stars, called its stellar day by the International Earth Rotation and Reference System Service, IERS, is 86,164.0989 seconds of mean solar time, UT1, or 23 hours 56 minutes 4.0989 s. Earth's rotation period relative to the precession or moving mean March equinox, when the Sun is at 90 degrees on the equator, is 86,164.0905 seconds of mean solar time, UT1, 23 hours 56 minutes 4.0905 s. Thus the sidereal day is shorter than the stellar day by about 8.4 milliseconds. Apart from meteors within the atmosphere and low-orbiting satellites, the main apparent motion of celestial bodies in Earth's sky is to the west at a rate of 15 degrees/h equals 15/min. For bodies near the celestial equator, this is equivalent to an apparent diameter of the Sun or the Moon every 2 minutes. From Earth's surface, the apparent sizes of the Sun and the Moon are approximately the same. Earth orbits the Sun, making Earth the third closest planet to the Sun and part of the inner solar system. Earth's average orbital distance is about 150 million kilometers, 93 million miles, which is the basis for the astronomical unit and is equal to roughly 8.3 light minutes or 380 times Earth's distance to the Moon. Earth orbits the Sun every 365.2564 mean solar days, or one sidereal year. With an apparent movement of the Sun in Earth's sky at a rate of about 1 degree/day eastward, which is one apparent Sun or Moon diameter every 12 hours. Due to this motion, on average it takes 24 hours a solar day for Earth to complete a full rotation about its axis so that the Sun returns to the meridian. The Moon is a relatively large, terrestrial, planet-like natural satellite, with a diameter about 1/4 of Earth's. It is the largest moon in the solar system relative to the size of its planet, although Charon is larger relative to the dwarf planet Pluto. The natural satellites of other planets are also referred to as moons, after Earth's. The most widely accepted theory of the Moon's origin, the giant impact hypothesis, states that it formed from the collision of a Mars-sized protoplanet called Gaia with the early Earth. This hypothesis explains the Moon's relative lack of iron and volatile elements and the fact that its composition is nearly identical to that of Earth's crust. The gravitational attraction between Earth and the Moon causes tides on Earth. The same effect on the Moon has led to its tidal locking. Its rotation period is the same as the time it takes to orbit Earth. As a result, it always presents the same face to the planet. As the Moon orbits Earth, different parts of its face are illuminated by the Sun, leading to the lunar phases. Due to their tidal interaction, the Moon recedes from Earth at the rate of approximately 38 mm/a, 1.5 in/year. Over millions of years, these tiny modifications and the lengthening of Earth's day by about 23 s/year add up to significant changes. During the Ediacaran period, for example, approximately 620 ma, there were 400 plus or minus 7 days in a year, with each day lasting 21.9 plus or minus 0.4 hours. The Moon may have dramatically affected the development of life by moderating the planet's climate. Paleontological evidence and computer simulations show that Earth's axial tilt is stabilized by tidal interactions with the Moon. Some theorists think that without this stabilization against the torques applied by the Sun and planets to Earth's equatorial bulge, the rotational axis might be chaotically unstable, exhibiting large changes over millions of years, as is the case for Mars, though this is disputed. Viewed from Earth, the Moon is just far enough away to have almost the same apparent size disk as the Sun. The angular size, or solid angle, of these two bodies match because, although the Sun's diameter is about 400 times as large as the Moon's, it is also 400 times more distant. This allows total and annular solar eclipses to occur on Earth. Earth's hydrosphere is the sum of Earth's water and its distribution. Most of Earth's hydrosphere consists of Earth's global ocean. Nevertheless, Earth's hydrosphere also consists of water in the atmosphere and on land, including clouds, inland seas, lakes, rivers, and underground waters down to a depth of 2,000 meters 6,600 feet. About 97.5% of the water is saline, the remaining 2.5% is fresh water. Most fresh water, about 68.7%, is present as ice in ice caps and glaciers. The remaining 30% is groundwater, 1% surface water, covering only 2.8% of Earth's land, and other small forms of fresh water deposits such as permafrost, water vapor in the atmosphere, biological binding, etc. In Earth's coldest regions, snow survives over the summer and changes into ice. This accumulated snow and ice eventually forms into glaciers, bodies of ice that flow under the influence of their own gravity. Alpine glaciers form in mountainous areas, whereas vast ice sheets form over land in polar regions. The flow of glaciers erodes the surface, changing it dramatically, with the formation of U-shaped valleys and other landforms. Sea ice in the Arctic covers an area about as big as the United States, although it is quickly retreating as a consequence of climate change. The abundance of water, particularly liquid water, on Earth's surface is a unique feature that distinguishes it from other planets in the solar system. Solar system planets with considerable atmospheres do partly host atmospheric water vapor, but they lack surface conditions for stable surface water. Despite some moons showing signs of large reservoirs of extraterrestrial liquid water, with possibly even more volume than Earth's ocean, all of them are large bodies of water under a kilometer's thick frozen surface layer. Earth is the only known place that has ever been habitable for life. Earth's life developed in Earth's early bodies of water some 100 million years after Earth formed. Earth's life has been shaping and inhabiting many particular ecosystems on Earth and has eventually expanded globally, forming an overarching biosphere. Therefore, life has impacted Earth, significantly altering Earth's atmosphere and surface over long periods of time, causing changes like the Great Oxidation Event. Earth's life has over time greatly diversified, allowing the biosphere to have different biomes, which are inhabited by comparatively similar plants and animals. The different biomes developed at distinct elevations or water depths, planetary temperature latitudes, and on land also with different humidity. Earth's species diversity and biomass reaches a peak in shallow waters and with forests, particularly in equatorial, warm, and humid conditions. While freezing polar regions and high altitudes, or extremely arid areas are relatively barren of plant and animal life. Earth provides liquid water, an environment where complex organic molecules can assemble and interact, and sufficient energy to sustain a metabolism. Plants and other organisms take up nutrients from water, soils, and the atmosphere. These nutrients are constantly recycled between different species. Extreme weather, such as tropical cyclones, including hurricanes and typhoons, occurs over most of Earth's surface and has a large impact on life in those areas. From 1980 to 2000, these events caused an average of 11,800 human deaths per year. Many places are subject to earthquakes, landslides, tsunamis, volcanic eruptions, tornadoes, blizzards, floods, droughts, wildfires, and other calamities and disasters. Human impact is felt in many areas due to pollution of the air and water, acid rain, loss of vegetation, overgrazing, deforestation, desertification, loss of wildlife, species extinction, soil degradation, soil depletion, and erosion. Human activities release greenhouse gases into the atmosphere which cause global warming. This is driving changes such as the melting of glaciers and ice sheets, a global rise in average sea levels, increased risk of drought and wildfires, and migration of species to colder areas. Human population has since the 19th century grown exponentially to 7 billion in the early 2010s, and is projected to peak at around 10 billion in the second half of the 21st century. Most of the growth is expected to take place in sub-Saharan Africa. Distribution and density of human population varies greatly around the world, with the majority living in South to Eastern Asia and 90% inhabiting only the northern hemisphere of Earth, partly due to the hemispherical predominance of the world's land mass, with 68% of the world's land mass being in the northern hemisphere. Furthermore, since the 19th century, humans have increasingly converged into urban areas, with the majority living in urban areas by the 21st century. Earth has been subject to extensive human settlement, and humans have developed diverse societies and cultures. Most of Earth's land has been territorially claimed since the 19th century by sovereign states, countries, separated by political borders, and more than 200 such states exist today, with only parts of Antarctica and few small regions remaining unclaimed. Most of these states together form the United Nations, the leading worldwide intergovernmental organization, which extends human governance over the ocean and Antarctica, and therefore all of Earth. Earth has resources that have been exploited by humans. Those termed non-renewable resources, such as fossil fuels, are only replenished over geological time scales. Large deposits of fossil fuels are obtained from Earth's crust, consisting of coal, petroleum, and natural gas. These deposits are used by humans both for energy production and as feedstock for chemical production. Mineral ore bodies have also been formed within the crust through a process of orogenesis, resulting from actions of magmatism, erosion, and plate tectonics. These metals and other elements are extracted by mining, a process which often brings environmental and health damage. Earth's biosphere produces many useful biological products for humans, including food, wood, pharmaceuticals, oxygen, and the recycling of organic waste. The land-based ecosystem depends upon topsoil and fresh water, and the oceanic ecosystem depends on dissolved nutrients washed down from the land. In 2019, 39 million square kilometers, 15 million square miles of Earth's land surface consisted of forest and woodlands. 12 million square kilometers, 4.6 million square miles was shrub and grassland, 40 million square kilometers, 15 million square miles were used for animal feed production and grazing, and 11 million square kilometers, 4.2 million square miles were cultivated as croplands. Of the 12 to 14% of ice-free land that is used for croplands, 2 percentage points were irrigated in 2015. Humans use building materials to construct shelters. Human activities have impacted Earth's environments. Through activities such as the burning of fossil fuels, humans have been increasing the amount of greenhouse gases in the atmosphere, altering Earth's energy budget and climate. It is estimated that global temperatures in the year 2020 were 1.2 degrees Celsius, 2.2 degrees Fahrenheit warmer than the pre-industrial baseline. This increase in temperature, known as global warming, has contributed to the melting of glaciers, rising sea levels, increased risk of drought and wildfires, and migration of species to colder areas. The concept of planetary boundaries was introduced to quantify humanity's impact on Earth. Of the 9 identified boundaries, 5 have been crossed: biosphere integrity, climate change, chemical pollution, destruction of wild habitats, and the nitrogen cycle are thought to have passed the safe threshold. As of 2018, no country meets the basic needs of its population without transgressing planetary boundaries. It is thought possible to provide all basic physical needs globally within sustainable levels of resource use. Thank you for watching this video.